Hello students, welcome back. In the last session we have discussed exception handling in Java. In today's session we will discuss the new concept, that is threads in Java. Threads allows a program to operate more efficiently by doing multiple things at the same time. So we can perform multiple tasks at the same time by using threads. Threads can be used to perform complicated tasks in background without interrupting the main task or main program. So it can be used to perform certain things in background and the main task in the foreground. So in today's session we will discuss about threads in Java. So let's start. First we will discuss what is a thread. A thread can be defined as smallest unit of executable code that performs a task. So we can define a thread as smallest unit of executable code that performs a task. Thread can also be defined as a lightweight process. So thread can also be defined as a lightweight process. You already know about a process. A program in execution, it is called as a process, whereas set of instruction, it is called as a program, and program in execution, it is called as a process. In case of thread, a program can be divided into subprograms which can be executed simultaneously, and this subprograms you can term it as a thread. That is why it is called a smallest unit of executable code which performs a particular task in a program. A complete program may be designed to perform a major task or a particular functionality, and it can be divided into subtasks, and these subtasks can be performed by threads. An application can be divided into multiple tasks, and each task can be assigned to a thread. So we can divide our application into subtasks, and each of those tasks can be assigned to a thread. For example, if we give some work to a person, that person may take say 2 days to do that particular work. If the same work is assigned to two different persons, or the same work, if it is assigned to two different persons, it can be done in 1 day. So if the work is done by a single person, it may take 2 days, and if it is assigned to two persons, it is done in only 1 day. So that increases the speed of performing tasks. Same way in program also, a program can be divided into multiple parts, and each of these parts can be assigned to a thread, so that all these parts are executed simultaneously. At the same time they can execute the task, so that the work is done faster. Okay, many threads executing simultaneously, it is termed as multi-threading. So what is multi-threading? When many threads are executing simultaneously, it is termed as multi-threading. Although it may appear that the processes are running concurrently, it is not so. Although we may say that all the processes are running concurrently or simultaneously, but it is not so. The processes are generally executed in sequentially, but there is a switching between the process, and that switching is so fast that we feel like it is executed simultaneously. And switching, it is generally done by the schedulers, the process schedulers in the system, which switches the processes from one process to another and from another process to some other process, and it happens so fast that we feel like it is executed simultaneously. And that scheduler and all, you have already studied in operating system. So what is scheduler? We will not go in detail with that part here. Okay, but actually today we have dual core or systems with some 2-3 cores, where we can execute programs simultaneously on these cores as well. Okay, multitasking versus multi-threading. You have already studied the concept of multitasking or multi-programming, or you can even term it as multi-processing, where multiple processes are executed simultaneously, or you can say multiple programs are executed simultaneously. Between multitasking and multi-threading. So multitasking is the ability to run more than one programs concurrently, and operating system controls the way in which these programs run by scheduling them. So multitasking, it is managed by operating system. Operating system schedules the program or the task in multitasking. Time between the switching of programs is minute, so it is very less, as I have said, and it happens so fast that we feel like it is executed concurrently. In case of multi-threading, it is the ability to execute different parts of a program called threads simultaneously. Now the difference, if you look at multitasking and multi-threading, in multitasking multiple programs are executed. In multi-threading, we execute multiple threads of a single program. So one program, it is divided into threads, and those multiple threads are executed, then it is called as multi-threading. Benefits of multi-threading. So benefits of multi-threading are: multi-threading requires less overhead than multitasking. So multi-threading requires very less overhead than multitasking. Less overhead in the sense, in multitasking, processes run in their own address space. In multitasking, processes are run in their own address space. In case of multi-threading, all the processes share the same address space. So memory is shared in case of multi-threading, and in multitasking, every program or every process has its own memory space. So multitasking utilizes more memory than multi-threading. Inter-process communication or inter-process calling involves more overhead than inter-thread communication. Inter-process, so communication between two or more processes, involves more overhead than communication between two or more threads, and this is because processes runs in their own address space and threads share the same address space. So these are some benefits of multi-threading. Some of the applications of thread, like threads can be used for playing sounds and displaying image simultaneously. We can do two things at the same time by using thread. One thread may play the sound, another thread may display images. So two things you can do at the same time. Then displaying multiple images on the screen. So we can have multiple threads displaying the images. So multiple different images can be displayed simultaneously by using multi-threading. Then it can be used to display scrolling text patterns or images on the screen. So moving text patterns can be displayed on the screen by using multiple threads or threads. Okay. Threads are implemented in the form of objects that contain a method run. So threads are created as an object, and this object contains an important method. The method is run method, and this run method is the heart and soul of this thread. So run method, it is heart and soul of a thread, because this is the method which is executed when we call or when we start a thread. When the thread is started, this is the method which is executed. It makes up the entire body of a thread. The run method makes up the entire body of a thread and is the only method in which the thread's behavior can be implemented, and this is the only method where we can implement the behavior of a thread. Now typical syntax of a run method, it is given here. So here you can see how a run method can be defined. So run method can be defined like public, return type is void, method name, run, and the method has body, that is flat bracket open and close, and it may contain any number of statements for implementing the thread. So these statements define the behavior of the thread. Okay, how we can create a thread? So thread can be created in Java by using two ways. First, by creating a thread class. So first way of creating a thread, it is by creating a thread class, and it is done by defining a class that extends thread class. So first way of creating a thread is by creating a thread class. How we can create a thread class? Define a class that extends thread class so that we can create a thread class, and override its run method. So the class needs to inherit the thread class, and it should provide or it should override the method run with the code required by the thread. Second is by converting a class to a thread. Second way is to convert the class itself to the thread, and that is done by defining a class, define a class that implements runnable interface. So define a class that implements runnable interface. So these are the two ways by which we can create a thread. First, you can say by extending to a thread class. First way is to extend a thread class, and second way is to implement runnable interface. By implementing a runnable interface, we can create a thread. The runnable interface, it has only one method, the method run, that is to be defined in the method with the code to be executed by a thread. So whenever we implement a runnable interface, this runnable interface contains one important method. The method is run method. So this run method needs to be overridden in the class where we are creating a thread. So these are the two ways of creating a thread. You may say, why two ways? Why we need two ways? Again, this depends on the purpose for which you are creating it. Suppose the application which you are creating, it depends on the application which you are creating. For example, if you are creating an applet, if you're creating an applet, your class should extend to an applet class. If you're creating an applet in Java, it is compulsory that the class should inherit an applet class. But if a class is inheriting an applet class, then it cannot again inherit a thread class, because first way of creating a thread is by creating a class which extends a thread class. So Java does not allow inheriting from multiple classes. So multiple inheritance is not allowed. So I cannot inherit from both, that is a thread class and an applet class at once. So in that case, we can go for a second method. The second method is by implementing runnable interface. If your class is already inheriting some other class, then the thread can be created by implementing or by using interface inheritance. Okay. Now extending the thread class, the first way of creating thread, that is by extending the thread class. How we can create a thread by extending the thread class, that we will study here. We can make our class runnable as a thread by extending the class java.lang.thread. So we can define a new class which extends the class java.lang.thread. That means this thread class, it belongs to a package lang, where package lang again it belongs to one more package, that is Java. This gives us access to all the thread methods directly. So by inheriting the thread class gives access to the methods of thread class directly, and it includes the steps. First step to create a thread is declare the class as extending the thread class. So we have to declare a class which extends thread class. Secondly, implement the run method that is responsible for executing the sequence of code that the thread will execute. Secondly, we need to implement the run method. We need to override the run method to define our code. Third step is to create a thread object and call start method to initiate the thread execution. So the last step is to create an object of a thread and call the start method, so that the method run or start method to initiate the thread execution. It initiates the execution of a thread by calling a method run. So these are some steps which can be followed to create a thread by extending the thread class. One example is given here. Declaring the class, the thread class can be extended as follows. So we have class myThread, and this is inheriting thread class. Now this is the first way of creating thread. Remember, the first way of creating thread is by extending thread class. So here if you look at this example, we have class myThread and this class is inheriting thread class. So this is the first way of creating thread, and it has the body, the class has a body. Implementing the run method. The run method has been inherited by class myThread. In the last example, we have to override this method in order to implement the code to be executed by our thread. Now to include the code in a thread, we have to override the method run, and we have to include the code which we want to execute on the thread inside the run method. Now the basic implementation of a run method will look something like this: public void run, and inside the run we have some set of statements which we want to execute. Now when we start the new thread, Java calls threads run method. So it is the run method where all the action takes place. So whenever we start a thread, automatically it calls a run method, and run method is one where all the action takes place. Now starting a new thread, how we can start a thread? We have defined a thread now. In the last example you can see we have defined a thread. To actually create and run an instance of a thread class, thread class, we must write the following code. Once our class inherits a thread, we need to create an object of our class. So you can see my thread, a thread, again this is an object, is equals to new my thread. So we have created an object of my thread with the name a thread. Then we are starting that thread by calling a thread dot start. A thread dot start will start the thread by calling the run method which is defined in the class, remember. So when we say start, start will call the method run defined in the program. Okay, let us go through an example. So directly switch to the program instead. Okay, so this is our program. We have a class A, and this class is extending thread class. So we can say we have created a thread here, and thread is created by extending thread class. That is the first way of creating thread, remember. And in the thread class you can see we have a method public void run. So we are overriding the method run which is defined in thread class. So in thread class we already have a method run, but we are overriding that method to provide our code which we want to execute when run method starts or when the thread starts. In this run method we have a for loop which starts with the initial value 1 to 5. Mean this for loop executes 5 times, and in those 5 times it will simply print a message, the value of I from thread A, and it will print value of I, that is 1 2 3 4 5, and after that it will print a message exit from thread A. So it will come out of the thread A. These are the closing brackets. Then we have created one more thread, class B extends thread. So this is our second thread, and this is the run method. Okay, and even inside this run method we have a for loop. This for loop is again executed 5 times because we have a statement that is j is equals to 1 to 5, but this will print from thread B and j is equals to value of j it will print. Next is we have one more class, the class C, and even this class is extending thread class. So we have one more thread over here, Again, even this is overriding the run method, and in the run method we have a for loop. So this for loop again it starts from value 1 to 5, but it prints from thread C, and value of k it will print. Okay, and again we have system.out.println exit from C. So we have three different classes A, B and C, and all of these classes are extending thread class. That means we are creating a thread there. Now we have our main class, the class thread test, and in this thread test class we have our main function. So this is the starting point of our program, and from here what we are doing is we are creating an object of every class which is defined before this, that is object of A, B and C. When we create object of class A, that it simply means we are creating a thread, because class A extends thread class. So creating an object of thread class, it is like creating an object of thread. Okay, so the syntax of creating an object, you can see we have created an anonymous object here, means object without the proper name, but the statements can be replaced with a proper statement which we have used earlier for creating an object. The statement is used, that is class name space the object name is equals to new class. So the first class for which we want to create an object is class A, or the constructor you can say A. Similar way we are creating an object of B. B is equals to new B. Is equals to new B. So we have created an object of B also, and in the same way we can create an object of class C. C is equals to new C. So we have created object of three classes. Then only creating an object will create a thread, but it will not start the thread, or it will not call the run method which is defined in the thread. To call the run method defined in the thread, we have to call, or we have to give a call to the method, that is start method. So we have to use a statement, that is a dot start, to start the first thread, that is A. To start B thread, we have to use b dot start, and to start the said thread C, we have to use C dot start. So these statements, how many statements? 1 2 3 1 2 3, that is 6 statements, can be written as only 3 statements by using this syntax. Both are same. In first case we have created objects separately, and then by using those objects we are calling the start method of a thread class. In second case we have created object and called the start method on the same line itself. So this syntax looks a bit difficult, but this syntax is useful syntax. Okay, we need to save our program now. So we have the program typed, and how to save the program. Save the program, go to file, and okay, let me close the brackets, save it. Now it is asking you to save location. You can save it anywhere, better create a folder and save. I'm saving it in E drive, and the name, what name I should give? Again it is Java. So the class which contains main method, that class's name has to be used. So here it is thread test dot Java. Okay, the program is saved. Now once the program is saved, we are ready to go, we are ready to execute. To execute it, we need to first open CMD. So open CMD and move to a path where you have saved your program. We have saved our program in E. Here we have to compile the program javac thread underscore of this thread, not underscore, thread test dot Java. And when I compile, okay, it is giving us error. The error is file not found thread test dot Java. So it is simply saying there is no file with the name thread test dot Java in E drive. Actually I have made a mistake in the spelling of a class name. Instead of thread, H is missing there. You can see in the file name here. It has become thread test. So I'll use the same name, javac thread test, okay, dot Java, and this will compile the program. And there is one error it is displaying. The error is semicolon missing, and this is at line number 10. So go back to the program, check the line number 10. So line number 10 is somewhere here. We have missing semicolon, so give a semicolon over there. Again come back and compile it again. Once we compile it, you can see there are still some errors which we need to remove. So errors, you can see cannot find symbol, out.println it is. So it has been wrongly printed here. It has to be out.println. Okay, that is one error. And another error, it was start. The spelling of start is also wrong at line number 46. So we'll move to line number 46 here, and it is start. Okay, okay, let us compile it again. You can see this time it has compiled successfully, and once it is compiled, we have to execute it by using a command java space the file name here it is thread test. Again this name should match with the class name also. I'll just check what is the class name here. Actually class name here it is thread, so I'll modify it. I'll make it as thread test because it should match. Otherwise at the time of execution it will give errors. So I'll compile it again. The program is compiled. Let us execute it. To execute it, the command is java space file name. And when I execute it, you can see the output, you can verify. First, we have actually started the thread A first, but then too it is printing output of thread B where j is equals to 1 for B. Then it has printed output of A which is equals to 1, then C which k is equals to 1, then again A, B and A again. So this is how multiple threads can be executed, can be created and executed simultaneously. all the threads you can see are executed simultaneously. That is the reason we are getting output which is not in a proper order, or it is not in a ascending order. It is not printing the printf statements of only the first thread first and then the second statement, second thread. Firstly it has printed the statements from second thread, then it has goes to first thread, then the third thread, again first, second, and first, like that. Based on the scheduling of a system, it will execute the threads. But here one thing to understand is all the threads are simultaneously executed here, not one by one. It has also displayed the exit from thread A, then exit from thread B and thread C. Okay, so this is how we can create multiple threads in Java, and each of those threads can be executed simultaneously by calling a start method which is defined inside that thread. Okay, so with this we will stop here today. We'll continue with the discussion of threads even in the next session. Today we'll stop here. Thank you.